Welcome to the first video for Mathematics 144. This video will be based on SmartTut 2. We will firstly be looking at exercises similar to the procedure exercises. The first exercise we're looking at is under the review exercises on page 505, and it's number 49, and it says find f's derivative in terms of g's derivative, where f of x equals e to the g of x. So this is an extremely straightforward and simple one. All we're going to do is we are going to take the derivative on both sides, and we are going to get f's derivative of x on the left, and then on the right we have the derivative of e to the g of x. The derivative of e to the power of some variable function is just e to that variable function, and then we're not done. We have to remember to apply the chain rule, so we still have to write down the derivative of g of x. And that is the first example done. The next one says find the nth derivative of f of x if f of x equals 2 to the x. So the first question here is, what is the derivative of a constant to the power of a variable again? So if you've forgotten, let's just quickly recap that. So if we have f of x equals 2 to the x, we can rewrite that as e to the ln of 2 to the x, which we can also write as e x ln 2. Now we can take the derivative on both sides, so we get f's derivative of x equals e x ln 2, and then still the derivative of x multiplied by ln 2. Ln 2 is just a constant, so the derivative of x ln 2 is just ln 2. And this first term here is simply 2 to the x, so it's 2 to the x ln 2. So in other words, whenever we have some constant value to the exponent x, the derivative of that is simply going to be that constant value to the x multiplied by ln of what the constant value is. So if we take our first derivative of f of x, as we've just said, it is going to be 2 to the x ln 2. Then if we take our second derivative, we are going to have 2 to the x ln 2 squared. Our third derivative, 2 to the x ln cubed, etc. And they asked us for the nth derivative, so that simply means that the nth derivative is going to be 2 to the x ln, sorry I forgot the 2 there, ln of 2 to the n. Next is number 56, and it says find y prime if y equals x plus arctan y. So arctan y, that's simply the same as inverse tan of y. Right, so here the important thing to note is that we don't have y explicitly in terms of x. So in other words, we have a y on the left and on the right, and it's not possible for us to isolate y and write it on its own on the left. So what do we do in a case like that when we are looking for a derivative? Well, we are going to apply implicit differentiation. So that means we are taking the derivative on the left-hand side. So on the left-hand side, we get y prime. On the right-hand side, it's going to be the derivative of x with respect to x, that's just 1. And then we have the derivative of arctan or inverse tan of y, which is just 1 over 1 plus y squared. Remember, we're not done since y is a function of x. Therefore, we still have to use the chain rule and multiply by y prime. Right. Our next step in implicit differentiation is to isolate y prime on the left-hand side so that we can write it as a function of y. So I have y prime, and then I'm just going to say 1 minus 1 over y plus 1 over 1 plus y squared. And then I have that equals 1. So all I did was I just took this term to the left-hand side and I took out a common factor of y prime. So if I make my y prime the subject, it's going to be y prime equals 1 over 1 minus 1 over 1 plus y squared. And what I'm going to do in my denominator is I'm just going to write this as one fraction. So if I write it as one fraction, it's going to be 1 plus y squared minus 1 over 1 plus y squared. So in other words, it's just y squared over 1 plus y squared, which means that we have 1 over y squared over 1 plus y squared, which is simply going to be y squared plus 1 over y squared, which is 1 plus 1 over y squared.